Hello and welcome to Component Rescue Board Repair. My name is Harrison and we will be fixing a board on stream tonight. The board we're going to be working on is an 820-2936, which is a 2011 MacBook Pro. So first thing we're going to do, we'll switch over to the microscope real quick and we'll plug it into our power supply. And looks like we're drawing 0 amps. And we have no light on the charger. So that's the first thing we're going to need to fix. So first thing we're going to need to do is go over here, this right here, this little chip. It's going to be the chip that makes PP bus G3 hot, which is the voltage that we need to be able to have a light present on the charger. Without that voltage, the SMC will not turn on. So we'll go ahead and stick one probe on ground, and I believe this right here is PP bus G3 hot, and we're getting 0.15 volts. That's not right. That means that something isn't working over here. So right here is where the voltage is going to be coming in from the charger. So what do we get there? Looks like we're pulsing between 16.6 and 16.2 volts. So that means that we're going to have a short, more than likely, somewhere, or that some component is blown, causing it to be looping like that. So something else I want to check out real too. I quickly looked over this board before I did this stream, just to see what I may be looking at here. And I did notice that there are some obvious signs of liquid damage, especially around this area right here. So if I zoom in a little bit, you can see right here that this pad is just completely gone. This cap I could probably knock off with my tweezers. I'm not going to though, because I don't want to accidentally rip anything up. And then these pads are looking pretty awful too. So before I do anything else, I'm going to go ahead and get all of this cleaned up so that hopefully this may be able to resolve the issue, but we won't know for sure until we get it all fixed. So I'll get that fixed in a second. There's a few more things I'm going to check out on this little circuit over here. And once again, this is going to be the chip that makes PP bus G3 hot, which is the voltage that's required for the SMC to turn on and for us to get a green light. So we'll get the charger plugged back in, and I'll switch over to the board view real quick so we can see which pin is which. So something I'm going to check real fast, since I already made sure there's the voltage in on, I believe it's, which pin is that? On pins 4 and 7, we do indeed have the voltage in. So something else I do need to check is I need to check the ton pin right here, because if we don't have the correct voltage there at this point, which we're going to need to flip the board over to get to it, then the computer will not turn on, because this pin kind of helps it figure out what voltage it's taking in, so it can help regulate what voltage it's taking out. And we can find that component right, let's see, we can find this component right there. And hey, what do you know? Looks like there's some liquid damage right over there. Let's see if this is in focus for you guys. Nope. There we go. So as you can see, there's definitely a bit of corrosion right over there. So we will check this pin right here. So this is the ton pin for PP Bus G3 Hot. And we have 15 volts. And 16.6 volts. Which, let me check the schematic real quick to see what we should be getting. So looks like, yeah, looks like that more than likely is going to be correct. So let's switch back over to the board view. So that, the voltage has dropped some, which is to be expected. So the next thing I want to check is the feedback right here. So basically what this does, is this the feedback pin? Or is it, oh, those are both. Maybe it's this ref pin? No, I think this is the correct pin. So normally what the feedback pin does is it's going to figure out what voltage the chip is producing and make sure that it is correct. Because if it checks this and it thinks, oh no, you're putting out 20 volts, turn off, then the computer will turn off to keep the computer from basically destroying itself. So we'll flip the board back over and we'll go back over here and we'll put you back on the microscope cam, and looks like we can find that pin on this little probe point right here. Which looks like we're getting 3.75 volts, which is a little high, but this still just doesn't seem quite right. Because we are now getting 66 millivolts on output, which that of course is not right. Right there we got 16. Here we got 3.75. So all of this is going to lead me to believe that there is an issue with this actual chip right here. So what I'm going to try and do is I'm going to try getting that chip replaced. The problem is though, is that this chip is not in a very good spot for me because it's right next to this RAM slot right here. And that's not in the view. So there's this little RAM slot right here. Here's the chip. This RAM slot, if you get it too hot, will break it. And we definitely don't want to do that because these are no fun at all to solder on there. So maybe, just maybe, we can figure out some other reason as to why this chip isn't working. However, there does appear to be some liquid damage right there, so I wouldn't be surprised if this chip is just completely dead. So we'll go ahead and get our hot air on, and we'll get this back in focus for you guys. And just to make this a little bit easier for me, I'm going to go ahead and take the heatsink off of the CPU. so that this will make it slightly easier for me in being able to angle this. Okay, there we go, got the heatsink off. So now we can use the hot air to go ahead and get that pulled off. And I'm going to add a tiny bit of flux here just to help give me an idea of whenever the chip is ready to come off. So let's go ahead and get that back in view. There we go. And hopefully we won't melt the RAM slot too much. It may get a little bit hot, but hopefully it won't be too bad. This is not my favorite spot to solder. Come on. Come on. Come on off of there. Come, little chip. Oh no, little chip. Why do you not want to come off of my board? Oh, there we go. Well, that's one way to get it off, is just to let it blow off. Looks like we got away without hurting the RAM slot at all. So, hopefully by replacing this chip, we will get PP3V42 back on this board. Let's add a little bit of flux right there. Grab our soldering iron and some solder. And we'll go over here. And I'm going to tilt this a little bit just to make it a little bit easier for me to solder. Okay, there we go. And now I can go ahead, add a bit more flux. And then I can pull that chip off of a donor board. Let's see. Does this donor board still have it? Aha, it does still have it. Okay. So I'll move that out of the way for just a sec. And of course the donor board doesn't really matter if I mess the RAM slot up a little bit on, since this board is just being used for parts anyways, since it has a dead CPU. So we do want to be careful and make sure that we don't break this part or just flick it off the board like the last one once all the solder gets melted. We of course want to make sure this gets properly pulled off the board, which, there we go, got the chip. Now we can set the donor board off to the side. And now we're ready to stick it on here. So we'll get that lined up right there. I'll go ahead and apply a little bit of heat just to kind of get it into place. And I'll move in with the hot air. Get it soldered on there. And now that it's on there, we can go ahead and push down on it. Make sure that it's nice and flat on the board. Okay, now it's nice and flat. Let me adjust that a little bit for you guys. I'll get the extra bit of solder removed off of there. And then we'll get the chip straightened up. So we got the little excess bit of solder removed. So now we'll add some flux. And we'll go back in with the hot air. There we go. And now we got the chip nice and soldered on there. And I'm going to go ahead and touch up all those joints around it and remove the little bit of excess solder just to make sure this is all nice and perfect on here. And I can't really reach in with those joints. Normally I like to touch them up, but in this case I think they'll be fine without the touch-up. So we'll use my super high-tech way to cool these off, because you never want to put power into something that's like over 100 degrees, because it could damage the chips. So here's my super high-tech way. And then I have this little thing right here, temperature sensor, which tells me what temperature that this is. So I can check it out real quick. I usually like to make sure that it's under 50 degrees Celsius. That seems to be kind of like a sweet spot. So there we go. It's at about 50 degrees now, and we don't really need the heat sink since we're trying to see if we get a light on the charger. If we get a fan spin and a light on the charger, then I'll go ahead and put the heat sink back on and we'll continue testing this. Let's go ahead and just stick the fan under here. So here we go, moment of truth. We plug it in. Oh, and still no light on the charger. But how much power are we drawing now? 0 amps. Okay. So I guess we can go back to PP3V42, which we can find right here. So I'm going to go ahead and get that measured on that little coil right there, which is showing up as the number 2. So that coil is right here. Which there is a bit of corrosion over there. Maybe that has something to do with it. But I guess we'll find out in just a moment. So looks like we still are Looks like we're getting 0.22 volts on this. You know what we'll do? Let's see. I'm going to check the schematic real quick. See what these are hooked up to. So I'm just going to go ahead and I'm going to rip that little capacitor off right there. So there's a little capacitor right next to this coil, which is connected to PP3V42, and maybe, just maybe, it doesn't like all that liquid damage on it. So we're just going to go ahead and rip that off. Come on. There we go. Okay, we got that capacitor off. So now we can actually take a look right there, see if maybe there's any corrosion that was causing this to not work. Something I do notice right here is that it looks like, do we still have a pad there? We do still have a pad here. But you know where we don't have a pad is right here. This right here appears to be completely gone. So I'm going to check the board view for that real quick. I'm going to see what that's for. So let's see. That's right underneath the inductor, right above two components. Okay. So that's for one of the chips on the PP3V42 regulator. And it goes to the regulator and to this little capacitor right there. So to me, it's kind of looking like that little line is broken. So first thing I want to try, because I really don't want to have to run a wire to the other side of the board, is we're going to try and see if we can save it. What about this little pad over here? Okay, just double checking, sure we were still good. Can we save this little pad? Looks like that little pad over there is fine. This little pad though is not fine. This little pad is missing. So what we're going to try first is we're just going to try to insert some solder into that joint right there and see if hopefully that will fix the issue. Did we just suck up a component? Let me check this donor board. No, we didn't. I'm just seeing things. But it looks like we're not going to be able to fill that little hole in. So, I'm thinking what I'm going to have to do instead is grab a little wire, and we're going to have to run a wire from there to the other side of the board. So let's grab my little wire from up here. And oh crap. where did I put my scissors? Sorry, I'm gonna have to unplug my mic for a second so I can go get up and find. Okay. Sorry about that. Which, by the way, I did get me a new mic. I don't know if you can see it, but it's right here. Got it clipped onto me. So hopefully we got a little bit better audio than we had in the past. Okay, clip me off a little piece. I got this really thin, here, I'll show it under the microscope, maybe you can see it there. Got this really thin wire. So what we're going to have to do is run this from the point that's broken to the point on the other side of the board. We'll grab the soldering iron, put a little bit on there. There's my iron. There's the wire. Which, even though it would be simpler to run the wire that way, just to make this easier for me to solder, I'm going to run it going the opposite direction that I need it to go, just to make it a little bit easier for me to solder. Okay, there we go. Got that wire soldered on there. And I'm going to go ahead and get this wire run around the board to where we need to go. Grab where's my other pair of tweezers? Here they are. Okay, and we'll get this run all the way to the other side. Come on, go down in there. Okay, there we go. There's our little wire right there. So let's see, which pin does this go to? This goes to the one on the end. So this is going to be the tricky part. However, I can easily see right here where there's a little trace that I can solder this onto. So I'm going to bend that out of the way for just a second, and we're going to take the tweezers and we're going to scratch away the black stuff on the top. And we'll add a little bit of flux. And then we'll add a little bit of solder to the part we just scratched away. I didn't get cleaned very well. Okay, now we got a nice little spot to solder to. So I'm going to grab the wire from right there. We're going to run it right there. and I'm going to go ahead and get it soldered onto there. And of course, to get it on there correctly, I need to scrape away a little bit of the enamel, just like that, so that we can get a nice clean solder joint. I'm going to use the tweezers to get this soldered on here. Let's go ahead and get this wire bent into place. Grab the other tweezers. Alright, get this little glob solder out of the way. Piece of sh. So tiny. There we go. Okay, now we'll add a little bit of flux. Now that we got this bent into place, I'll get some fresh solder on my iron, and then I'll hold it in place with the tweezers. While I solder it onto the board. Oh, come on. Why does this have to be so difficult? Okay, there we go. We got some solder on there. We'll pull this right there. And we got that in place. And that's a really crappy solder joint. There we go. This looks a little bit better. Let's see. Yeah, this looks strong enough to actually leave on the board. There we go. Or maybe not. You know what we're gonna do? I'm gonna pull this back with my fingers a little bit, and we're gonna scrape a little bit more off of this board. And we'll add some flux. Get some fresh solder. Okay, there we go. It's on there, beautiful. Now, go back in with the tweezers. There we go. And now I just need to touch this down with the iron. Almost. So close. So close. There we go, that looks pretty close. Get the iron in there. And we'll get that soldered on there. And that should be a pretty strong solder joint. See how the whole thing doesn't, well, it's not the best. Or maybe it's not even soldered on there that well at all. But it's okay, we can touch it back up. There we go. And now I'll touch it up from a different angle. There we go. Okay, so now we got that piece of crap soldered on there. Let's see, let's make sure. There we go, everything's still working great. Okay, and now pull our dead components off and let's plug the board in, see if we get a light. And we still get absolutely no light. But let's at least flip it over and see if we're getting PP Bus G3 hot. Still 0.23 volts. Why could this not be working? I'm gonna look back over this area right here under the microscope, see if maybe, just maybe, there's something I'm missing. I mean, I know I knocked that little component off over there. What's this probe point for up here that looks like complete crap? S5 power good. Well, we don't need that for PP Bus G3 hot. However, we may need to come back to that later. You know, I'm gonna jump back to this liquid damage I found over here earlier, and I'm just gonna go ahead and fix that and just really hope and pray that that'll fix the problems with this board, since it's kind of somewhat related. I mean, you can still see, this is obviously been ultrasonic, but I mean, like, you can still see whatever liquid was spilled on this. Based on the casing of the computer, it was probably like juice. I mean, that would have been my guess. In fact, you can still see a little bit of corrosion over there, and ooh, that looks pretty bad right there. And seeing this corrosion on the battery connector is not very promising for me. So you know what, before I even go through all of this trouble, I'm just going to check and see if maybe we had 12.5 volts sent to one of these. So let's see if we got a short to ground on either of our battery data lines. Which it looks like we don't, which is pretty good news for me. That means that this may actually be fixable. So let's go back over here. And as you can see, this trace does not exist. And I can probably knock this component off the board just like that, because it's that corroded away. So I'm going to go ahead and take this rubber crap off of this audio IC. Maybe I am, if I can get it off. And you know what, screw it, that doesn't want to come off. And that component's probably fine. But what's not fine is, you know what, this ISL is obviously liquid damaged. So we're probably just going to go ahead and replace it anyways. Where else do we have? Let's just go ahead and finish searching the board for liquid. Oh. Ooh. This isn't good right here. I could probably also knock this cap off the board. Yep, just like that. So corroded away. So let's go ahead and see what this is for. Maybe this is something important that we need. This is for PP3V3S5. So maybe not quite yet. Here's a little pad that's been partially corroded, but is still there. Here's some more pads that are partially corroded. Some resistors that got a little bit of corrosion, but that's just a temperature sensor up there, so that doesn't matter. Here's a little bit of corrosion up here around, around the SMC, but that all appears to be fine. Let's see. Oh, what is this component right here that appears to be a resistor that is fractured? That's for PP bus G3 hot. Okay. So let's check over this side of the board, see if maybe we can see anything. Anything around the clock chip? These have a little bit of liquid on them, but they still look okay. Any liquid over here around CPU V-core circuitry? Nope, I don't see any. About over here, PCH circuitry. Aha, there's a little bit right there. You can see a little bit on these components. Nothing that would cause them to not be working though. Here's some corrosion, and see, look at this, look at this crap. There's some corrosion down in there. There's this little wire I ran that doesn't seem to be working. What about if I touch this wire up? Maybe if I touch it up a little bit, I can get it to work. Because I'm still thinking that this is going to be the reason that this wasn't working. And just to be sure that that is indeed making a connection, stick that on there and that right there. So we are indeed getting a good connection across there. And that's not shorted together. So we should be fine right there. Let's try it again now that I've kind of touch that solder up a little bit. Maybe now we'll get a green light. Nope. What about with a so with a real Apple charger we get no green light. What about with a fake one hooked up to my power supply? What do we get with that? Zero amps. Absolutely nothing. Okay, let's try testing, see what we get hooked up to the power supply. So on PP3V42, we're still getting 0.23 volts. I'm still thinking we replace the charging chip and touch all that up and see if maybe that'll fix the problem. Okay, so that's gonna be right over here. Which, as you can see, that all looks like crap. So we're gonna have to replace that chip and probably run a couple of little wires. But, I mean, that's all okay. We can easily do that. And hopefully that'll fix our problem. And I can be done for the night and finally go to bed. Because I had a very long day at work today. And I really kind of just want to go to bed. While I'm over here, let's go ahead and get this crap ripped off. We don't want it. We don't want it. There we go. Oh. Okay, we can at least see my itsy bitsy little resistor right there. Okay, let's go ahead and pull this chip off. Why am I using these? Those are not heat resistant. In fact, I accidentally ordered me the wrong tweezers. I'm gonna have to get me another one of the right ones. But come on. But if this doesn't fix the issue with this board, this board's gonna be absolute hell. Okay, those pads actually don't look too bad. I think we can clean those all up real nicely. If this doesn't fix the board, I may try a few more things, but I may just have to end the stream and just get back with everyone whenever I just finish fixing this board. So I'm gonna be honest, like I said, I'm pretty tired right now. I don't think I'm so tired it's affecting my ability to fix this, but at the same time I kinda want to go to sleep. At the same time though, I need to fix this board, because if I don't fix this board, I don't get paid. Because that's what happens when you have no fix, no pay. Okay, grab one brand new chip. Brand new charging chip. And I'm an idiot and forgot which direction the chip goes. Let's check on this little donor board. You might be asking, why don't I just pull the chip off a donor board? Well, that's a great question, because why would I get a used chip when I have a brand new one that I know is going to be working? So it looks like it goes this way. So we'll add a bit of flux. Set this off to the side a little bit. And then we'll go in and get this brand new charging chip put onto this board. First, usually I go in a little like that just to get it on the board. And oh wait, you guys can't see that. We're working right here. Okay, so right now it's just on the board. Then I'm going to go back in. A little bit of heat to get it kind of on there in place, and then we're going to press down and go back in one more time. It's time to get it nice and flat on the board. And now we'll add a bit of flux and get that all nice and cleaned up. And looks like this isn't perfectly straight whenever it went down, so we'll go ahead and get that fixed too. First though, we definitely want to get all the excess solder that we don't need off, so that way the chip can sit flat. And we already have a little bit of extra flux. So now I'll just go in and the chip should line itself up on its own. come on. There we go. Good little charging chip, and make sure it's flat. And I'll go back around and make sure that all those joints are beautiful. Since we definitely don't want subpar joints here at Component Rescue. Okay, beautiful. And we'll go ahead and get this crap over here done too. So to get this working again, we'll really zoom in. So that we can see, oh god, that's hot. This little trace right here. And just like the other time, may have to let this cool off so I can actually touch it without burning myself. Let's try this at a different angle maybe. There we go. And I'm going to do a real quick test on, so this right here, that's of course not working, is the current sensing circuit for the charger that detects how much current the charger is drawing. So it's expecting a very specific resistance. However, if you break one of the traces here, it thinks you have a very high resistance, such as what's going on here. See how this one beeps? Now this one doesn't, because the trace is broken. So to fix that, we are going to have to, first I'm going to add a little bit of flux. I'm going to add some solder in on here, and I'm going to replace that little capacitor first, since it's going to be hard to replace that little capacitor after I run a wire. Let's zoom out a little bit for this. In fact, let's see if this resistor right here is even good. We may need to replace this too. Nope, looks like that resistor is also blown. So I'll go ahead and get that pulled off too, so we can get that replaced. This other one that was under this rubbery stuff looks like it's fine. This one we definitely are going to want to replace. Add a little bit of flux, and then we'll start away with the scraping soldering iron. There we go. And I'll grab a donor, and I've already stolen it off that one. What about this one? This one still has it. So push this back a little bit. Stick that back under the microscope. Get it nice and in focus. And I'll go ahead and steal that little resistor and that cap. There we go. We'll get those all nice and straightened up. So now that we got that replaced, now it's going to be time to run the wire. So I'll cut me off. Where did I put my scissors? Just cut me a piece of wire earlier, so I know I have them over here. Aha, here they are, underneath my donor boards. Okay, cut me off a little piece of wire. And now we're just going to run that wire between all the different little points on there. Move the donor board out of the way since we don't really need it right now. So the first thing I want to do is I want to add some solder to this little part over here that we're going to be soldering to. That beautiful little spot right there. The next thing I want to do is I'm going to grab my wire and I'm going to basically just tin the end of it by scraping off the enamel with my soldering iron and making sure that it has a little bit of solder on it. Okay, there we go. And I'm going to flip this a little bit to make this easier. Where did we go? There we go. We got a little bit of solder on here. Okay, there we go, that's on there now. So next I want to solder this onto this little capacitor right here. There we go. And then finally I want to solder it onto this resistor. Unless those are already connected, because it's usually easier to just connect it to one component than multiple. So let's see, we still got this in diode mode. We'll touch one right there and the other right there. So looks like that does have continuity, so we can just go ahead and break this off. And I do want to zoom in a bit and make sure that is indeed soldered onto there correctly. Okay, we don't need the hot air. We need these soldering iron. There we go. Beautiful. Beautiful. I'll zoom back out. And I can break this little wire off. Now that we're all nice and soldered onto the board. And I'm going to go ahead and see if this works. If it doesn't, I'll probably try messing around with it some more. And if I think I find a solution after this, wait, go. And looks like there's still no light on the charger. As so, I guess we're going to be coming back to this at a later time, since I am quite tired right now and really would like to go to bed. So we don't have a fix for this just yet, but there should be one in the next video. So, hope you guys enjoyed the stream. I'll